this is it's a quick Kubernetes overview, and I kind of want to go through, like, when people start with an outline, I'm always kind of like, it's really just spoilers. Spoilers for the talk. We're going to talk about how we got to this point, and where here is, and where I think a few things might be going. So it is, by the way, and if you've been in tech for a while, and I've been in tech for a while, it's really tempting sometimes to spend a lot of time looking back. We don't want to spend too much time on that. A few of you maybe were here for some of this stuff. Maybe not all of you, which is fine. Some of it's like, you're like, this is ancient history. But I'll kind of jump right into more recent history of me doing stuff with containers. I did used to actually work for a living. No, the last ops gig I had, I worked at a streaming video company called Drama Fever. And it was sort of like Netflix, if Netflix were much smaller and mostly Korean soap opera, and started running Docker in production in October 2013, when I'm pretty sure the main thing on Docker's website was like giant letters in Blink that said, under no circumstances should you run this in production. And they were like, YOLO. And I joined in June 2014, because I was like, this tech is exciting. These people aren't afraid of things. And they got acquired by Warner Brothers, so I guess sometimes YOLO works out. I can't recommend YOLO under all circumstances, but it does mean I got to deal with a lot of really exciting early Docker bugs. This is well before 1.0. And I would say what I learned from that is containers are really great for some very specific purposes, right? They're really great to produce consistent environments and really repeatable deployments. They're maybe not necessarily great for a few things that you might care about, like, say, new failure modes. Somebody has a container image that they built locally that didn't make it through the CI/CD pipeline, but there are some instances out there in production somehow with that image. They were debugging, who knows? Like, there's a lot of, you can always move your exciting failures around to somewhere else. So, by the way, like, this container stuff also, I feel like people feel like it burst onto the scene in 2013 or so, and that isn't really true, right? Like, I mean, these are actual textbooks I used when I got my CS degree back in the 90s, and which, by the way, I worked for the CS department, and I'm probably standing here today because they gave a bunch of undergraduates, wrote on their faculty members' computers. I don't know, it was the 90s, like many things seemed like a good idea at the time. Again, that also worked out. And we were actually using containers then. We were using Solaris zones. We were using FreeBSD chroot jails. So like a lot of us, when the old timers start saying to you, oh, containers aren't new, back in my day, like, yeah, I mean, we were actually, LXC, like they were a thing, but they weren't widely adopted. And I think there's a good reason for that, right? Like, they were kind of a pain to use. They were not actually easy or super accessible. They got easier when we ended up with a bunch of projects kind of coalescing about the same time that started making containers more usable by people, more accessible. And containers are basically common parlance at this point. I mean, I was just at KubeCon EU, and people are all talking about orchestration. People are talking about Istio. Like, everyone's all containers. I mean, obviously, yes, of course we have those. And I think that's sometimes the feedback bubble that we find ourselves in. If you are the sort of person who goes to conferences that have lots of talks about containers, you assume everyone's doing that. And then you maybe look at your actual workplace, or you talk to your friends who work at places that are not under any circumstances going to allow them to even use public cloud yet. And it's like, the future might be here, but it's not evenly distributed. So when Kubernetes came on the scene, and this is, again, it's a little interesting to look at how long ago this was, right? Like, I think I was at the OSCON in 2015. That was like their 1-year anniversary. But it's not actually that new. But at the same time, obviously in 2014, none of us could have looked at Kubernetes. Well, maybe some people did. But most of us couldn't have looked at it and said, oh, this particular orchestrator is the one that's going to take the world by storm, versus all the other ones that exist, that still exist, that are out there. I would submit to you that Kubernetes is not our end game. Like, it is a step. I mean, as an it's not even the only orchestrator that people are still using in production, even people who are using Kubernetes. I would say that, like, 4 years in, it's clearly one for some values of one, like however you want to define that. So looking at those, I think that it's super important for us to remember, especially as we start implementing them in production. And I saw a lot of hands go up when people were asked, when our first speaker asked about people's familiarity with Kubernetes. And I'm imagining that those of you who are using it in production are quickly finding all the edge cases. But I think it's important to remember that, like, we want to incur the minimum viable complexity that'll get us the results we actually need. Or maybe we're doing resume-driven development, and we definitely want really exciting infrastructure that we can walk away from in a few months. But let's just presume that that's not what you're trying to do. So this kind of brings us up to today. Like, if we look at the container and orchestration landscape today, and I don't know about you, but I have this like Pavlovian response now when someone says landscape, I say CNCF. It's like landscape. But I think that looking at the stuff and I just pulled this off their website in the last couple of days, so like it's a moving target, but looking at what people are excited about, what people are talking about in this space, it's like, all right, we're considering that Kubernetes is stable. It's the first thing that's graduated, whatever that means. But I think that most of the projects in the space, and there's a lot in there, and it's an eye chart, and you can go look at the CNCF website and look into more detail about all of them. But I think what they have in common is like focused on containerization for those same reasons that we found at the little streaming video company of reproducibility, isolation, not having one set of concerns bleeding over onto another. The dynamic orchestration is really nice. If you've spent any time setting up your auto-scaling groups and then having to constantly reconfigure them and having to constantly change exactly what triggers what, like, dynamic orchestration starts to sound really nice if you've spent enough time doing that. And the idea of being focused on microservices. And I almost feel like we're in the hype cycle. We're getting to a place where we're going to have some microservices backlash. People are going to be like, I went back to a monolith, and here's how, and here's why. I don't know. I kind of see that coming, and it's like, microservices are great, and they're also not a magical solution to absolutely everything ever. But anyway, lots of good projects in the space that are worth checking out if they solve problems you actually have. Kind of a theme there, right? Because, like, if this ecosystem seems complex, I mean, that's because it is, right? And like, I've given a bunch of talks about culture where I say, like, computers are the easy part, people are hard, but that's kind of a lie. I mean, what's actually true is computers are hard, and then you add people, and they're even harder, and everything is on fire, and the "this is fine" dog is laughing at you. Like, that's what it's actually like. You get the the combinatorial complexity that we just heard about. So I think a good example of that is actually with microservices, because as a former boss of mine, Tim Gross at Drama Fever, likes to call it, we have conservation of complexity. You're still going to have the complexity, you're just going to move it somewhere else. Like, oh, that's adorable, you just traded in your IPC for a bunch of network lag. Like, you still have a problem, you just have a different problem. And so you get to choose which problems are the least terrible for you to have. I mean, I'm an ops person, so I'm kind of a natural pessimist, so I'm not going to say which are the best things. It's just, what's the least terrible choice, right? And something like Kubernetes does help you manage that complexity. Okay, so like, say we're going to get started with Kubernetes. There are some really great from-scratch exercises. Kelsey Hightower's Kubernetes the Hard Way is a classic. There is an Azure fork of that. I work at Microsoft, so I got to tell you that there's plenty of places, lots of clouds, you can try this Kubernetes the hard way out. I think that the fine folks at Alex Williams and company at the New Stack have done a pretty good job. Even though it's a little dated now, they've done a pretty good job with their intro to Kubernetes. So I'm going to do the 10,000-foot view, quick walkthrough of a few architecture diagrams that they have. So if you're new to Kubernetes, or maybe using it but not spending a lot of time with the control plane, like the master node or control plane, because obviously you can have and maybe should have a multi-master setup in production, but your control plane exposes an API, you schedule deployments there, like do all the cluster management there. The nodes have a lot of their own roles to play, and this is where it kind of comes into like, what sort of redundancy do you want to have exactly? And you can tag a whole bunch of your processes as these will only run on the control plane, or these will not run on the control plane. And there's, of course, reasonable, for some values of reasonable defaults for all that. So it's like, okay, that's a bunch of exciting complexity with built-in service discovery. And again, like those of us who have spent some time wiring together, a bunch of DNS-based service discovery or whatever, would like to spend less time on that. This is again like, we're all smart people. We can all do these things. We have to decide, where are we going to spend our energy? Where are we going to spend our effort? Like, which level of the stack does it make the most sense? And are we getting the most value for our organization by putting our effort into? Okay, so like that's, architecture stuff for like the master. Looking at the master a little bit more specifically, the objects are scheduled by the master on specific nodes, so like your pods or replica sets or whatever. The nodes are getting the images from your container registry, which you can define. A lot of enterprises are going to use like a private one or whatever. And launching the containers, again, coordinating with the container runtime, which doesn't have to be Docker. You could use Rocket or Cryo, or you have a lot of choices there. Sometimes too many choices, but again, this is kind of Kubernetes tries deliberately so to be unopinionated about any place that it can be pluggable for you. One thing that's pretty opinionated is the distributed key value store that they use is etcd. I think there are projects to do something else, but it's like, again, what is valuable to you? What are you going to spend time on? You have to have some place that's your single source of truth. Okay, so for your worker nodes, I think the thing that's a little bit confusing to people who have more paid attention to something like Docker but not Kubernetes yet is that you have a pod that can have one or more containers in it. They're going to share the same context, which means specific things, and resources that they have access to. And your pods can be scaled. You can be scaled in replica sets, which makes them identical, or there are other methods of scaling, depending on if you're trying to build one-off things or run something like cron. There's stuff you can do with things called labels and selectors. And if you're thinking by this point, yeah, I know all this, like, okay, that's cool. There's a few things that are sort of interesting, like there's stuff you can do with the kubelet that, like virtual kubelet, that we'll talk about in a little bit. And then, of course, like FluentD used for logging. Obviously, I want to say, I read proposals for KubeCon EU this year, and I think about half of I read like 60 or 70 and voted on like 60 or 70 of the proposals, and I think about half of them were about service saying words is hard, service meshes, and the other half were about exactly what you do with your logging, for what it's worth. So, okay, so mind blown, like lots of vocab. If you go to a Kubernetes workshop at a typical conference, it might be a few hours long, you do a lot of stuff interactively, you've learned a lot. You go back to the office, maybe they want you to write a trip report, or maybe they want you to share what you learned with your coworkers, and you're like, oh boy, that's great. I can't actually replicate that. Like, I can't actually build everything that I had at the conference for you, and then they're sad. Okay, so one of the things that I've been working on is democratizing that, right? Because like, if we're going to presume that Kubernetes makes it easier for you to run the kind of distributed systems that really just big players would run before, okay, what if we want to democratize learning about Kubernetes? So obviously, the answer to that is open source Kubernetes training. Some of you may know Jerome Petazzoni. He was one of the early employees at a company called .cloud, which later became Docker. And he's spending a lot of his time these days doing Kubernetes training inside companies. So, and I've been working with him on this open source project. So it's on GitHub, and you can run this training yourself. There's instructions for spinning up instances. There's it's a Kubernetes 101, which is to say, tries to start with things people might already know and build from there, and not give them 8,000 things to configure because like if you start with, say, Kubernetes the hard way, you're going to spend a lot of time just setting up the clusters. So this, it just walks people through operating microservices on Kubernetes, gives them concepts and terms and again, it's a big and complex space, and so this, open source workshop is meant to be, and I'm not going to walk through them, but I'll just show you chapter 1, just getting people to using kube control, or I like calling it kube cuddle. I realize this is controversial. Getting people to run containers, expose containers, what are we going to do with a registry, the kind of things you would have to think about if you're operating this sort of thing in production, exposing services, the Kubernetes dashboard, how to not have the Kubernetes dashboard explode insecurely in your face, and then moving on to some fun stuff like, Helm and Draft. So if you're going to run this yourself, there's directions available in the repo for Azure and AWS. Pull requests accepted. If someone would like to send us instructions for other clouds, we would appreciate that. I know some of our friends from Google are here. And I don't have a ton of time left, so I'll just say, the what's next is, I would say Yoda had it best, right? Always in motion is the future. I think every time people try to predict the future, they're pretty much wrong. I can tell you that we do have some upcoming events coming, and we would love to have other people run this training at events or inside their companies. So send us pull requests. And take a look at, by the way, Lucas Kaldstrom has a pretty good, and I'll put these links up. I podcast too much, so I was about to say a link in the show notes, but no, I will tweet a link to these slides so you can see. I think Lucas has a good overview of even more about the API resources, maybe a more 5,000-foot view instead of my 10,000-foot. Projects that I think it's a good idea to take a look at. Helm lets you deal with the complexity of all that YAML. And these are open source projects. I have Microsoft coworkers who contribute to Helm and to Brigade, which helps you if you don't want to just have YAML. You want to actually have some ability to act in there too. And virtual kubelet is definitely cool. And I'm not going to go into a ton of detail about it because I'm pretty much out of time, but I'll tell you that if you would like to plug your DCOS cluster or your entire data center full of VMs or anything else into your Kubernetes clusters and have them treated like a Kubernetes node, this is the way to do it. So that's a good open source project to check out as well. And my coworker, Eric St. Martin, is one of the people who worked on the virtual kubelet project. And he's one of the people who runs GopherCon, and he likes to say that Kubernetes is not the thing, it's just what's going to get us to the thing. And we're all technologists, we love playing with really cool tools, but I think it's important to think about how we're going to build on those to build the next thing. And with that, I'll just say, I work at Microsoft. We're not using my computer right now, but I do have a Mac with a Microsoft asset tag on it. And my job is to help people use Linux and containers on Azure. And if that doesn't convince you that we are in the weirdest timeline, I don't know what would. But it's pretty cool. It's pretty exciting. And we are hiring. So call to action, because you got to end with a call to action, is please take a look and contribute to the container training project. Take a look at virtual kubelet, because it might help you plug in those things that nobody will let you get rid of. And please join us, because we're hiring. Thanks.